Now let's see some application guideline for the grinding. First, to optimize surface finish, it is much better for you to use small grid size and dense wheel structure, and high wheel speed, lower work speed, smaller depth of cut, and larger wheel diameter. For the first one, it is much better to use the small grid size. Why? Because if it is a small grid size abrasive, when it touch the surface, the amount of the material going through the material, the workpiece is smaller. So then there is less wave on the surface of the work material. If it is a big abrasive, when it touch the material, the workpiece, the ploughing area will be bigger, so then the wave on the surface will be bigger. So that's why the surface roughness will become rougher if the abrasive is larger. So dense wheel structure, if it is a dense wheel structure, so then all the abrasive will be close together. So when it work on inside the material, the amount of the the wavelength of this area will become smoother. If it is less dense, like there are area in between the the abrasive, when it touch the surface, it will become rougher. Okay, like this one, there is a gap in between, so then the surface become bigger. Okay, so that's why the surface roughness will become rougher if it is less dense wheel structure. So now, why high wheel speed? At high wheel speed, the temperature on the surface will become higher. So when the temperature is higher, the surface will become softer, so it's easier to work on, and therefore the surface roughness will be better. Okay, so lower work speed meaning work speed means how much you move the workpiece towards the wheel. Okay, so let's say this is the wheel. So if you move the surface here slower, toward this direction, so then there are more time for the material to touch the abrasive. So then more clear, more area will be touching the abrasive, and it will become smoother. Okay, so smaller depth of cut. So of course, if you use smaller depth of cut, then less material is removed at one time. Okay, so less layer coming out from the work material, so therefore there are the surface will become smoother. If you use a very big one, so then it will become rougher. Okay, so that's why we use small depth of cut. And large wheel diameter, so if it is a big diameter, so there are more area of abrasive compared to the small one. If it is a small one, so we keep repeating the same area, so then they might be cheap, and there are also dullness of the abrasive compared to the big one. So that's why it is recommended to use the large wheel diameter. So the second one, to maximize material removal rate, it is advisable to use large grid size. As I mentioned previously, if you use a big one, then the amount of the material that going inside the surface is bigger, so therefore the material removal rate will be higher. More open wheel structure, so if there is more open area, so the amount of the abrasive going inside is more open, so then it's much easier for the chip to coming out. So that's more important for the material removal rate. So it is also recommended to use the vitrified bond, because vitrified bond is among the hardest, the better bond, which if you use you produce a high material removal rate, it still can bond the abrasive to the wheel. In terms of the material, for steel and most cast iron, aluminum oxide is usually used as for the abrasive. For most non-ferrous metals, silicon carbide is used as the abrasive. And for the aerospace alloy and hardened steel that very hard, or we call it as super alloy, CBN or cubic boron nitride is used as the abrasive. And for hard abrasive material, the hard abrasive material, we use diamond as the abrasive for the wheel. Now, for soft metal, usually large grit size is used for the abrasive. Why? Because when it is large grit size, then more material can be removed, and apart from that, abrasive also can withstand the soft metal. So but you have to use harder grade wheel. Okay, so for hard metal, it is advisable to use small grade size but softer grade wheel. Softer grade wheel, so that when the abrasive touch the metal, it can easily break, meaning the friability is higher, so that they can expose new sharp edges better, so that more material can be removed for the hard metal. There are four types of surface grinding. The first one is horizontal spindle with reciprocating work table, and the second one is horizontal spindle with rotating work table. As for this one, spindle is rotating in horizontal horizontally, and then the work table is moved back and forth for A, and in circular for the B type. And the third and fourth type of surface grinding is vertical spindle with reciprocating work table, and vertical spindle with rotating work table. So if you can see, the type of the work table is the same, but the spindle type is changed. If you can see, it is vertical, so meaning that it's moving like this one from vertical. Okay, so but then the work material is the same, like A and B. Okay, so meaning that it's moving from front to back, and then this one is rotating. Okay, the most common grinder type is the surface grinder with horizontal spindle and reciprocating work table, like the one that's shown in here. So now previously we see the flat grinding. So for cylindrical grinding, there are two types. One is external and another one is internal. So for external is used to grind the outer surface, and the internal to grind the internal surface of the work material. For external grinding, there is one configuration what we call as external centerless grinding. So this one is usually used for a long workpiece, where the workpiece is placed in between the grinding wheel, and also there's one regulating wheel where it is inclined, is positioned in incline. So what happens is, when regulating wheel is moving, so the work material will automatically move out towards the end of the feed. Okay, another setup for the grinding is what we call as creep feed for grinding. So the normal the normal grinding, usually the depth of cut is very small. In order to finish this depth of cut, okay, the material, let's say you want to remove this thickness of the material, you have to remove little by little, and it will take a long time. So but for the creep feed, you will be able to remove all material in one go. Okay, so but it has to move slowly compared to this conventional one. Okay, so that's the creep feed grinding. In a creep feed grinding, the depth of cut can goes up to 1000 to 10,000 times greater than a conventional surface grinding. So but the feed rate reduced by the same proportion. So for material removal rate and productivity increase in the creep feed grinding because the wheel will move continuously but in a slow motion. So in conventional surface grinding, wheel is engaged in cutting for only a portion of the stroke line. Let's go to the other abrasive processes. Okay, so we start with the honing process. Honing process is a process to create a characteristic crosshatch surface inside the on the surface. For example, in internal combustion engine of the car. Okay, so the purpose of the crosshatch is to retain the lubrication within that surface. Okay, so the grid size is range between 30 to 600 for the abrasive, and surface finish of the surface is around 0.12 micrometer or better. Picture A showing the tool used for the internal bore surface, and B is showing the crosshatch pattern created by the action of the honing tool. So what happened is the tool will move up and down inside the combustion. Let's say, for example, this is the internal combustion uh, of the engine. Okay, so what happened is this area will move on the surface here. Okay, so to create the crosshatch, because it's going up and down, and also this one is going to scratch into the surface here, so then it will create the crosshatch surface like this one. So we are going to see the video later for better understanding. Next is lapping process. Lapping process is a process where you want to create a very fine and good surface finish on a certain area. For example, is optical lenses, metallic bearing surface, and gauges where the material must be very good in surface finish. Okay, so in lapping, there'll be abrasive and fluid mixed together to get a chalky paste, and then is placed between the tool and also the work material, for example the lenses. Okay, so typical grid size is between 300 to 600. The picture here showing the lapping process in lens making. For example, if you can see here, there is a lens, and then there is a lapping tool, and also in between there are the chalky paste of abrasive mixed with the liquid. So if you during the process, if you, let's say, this is the lenses and this is the tool, in between there will be a paste in between the tool and also the lens. So this tool will be moving in infinity movement on the surface. Okay, so like this one. So it will be moving like number X movement to create the surface, the good surface on the optical lens. Now, the last one is super finishing. It is similar to the honing. Use bonded abrasive stick press against the surface and reciprocating motion. But the difference with honing is the stroke is shorter, it's higher in frequency, lower pressure between tool and surface, and smaller grid size. This picture shows the illustration on the super finishing on an external cylindrical surface. So if you can see here, there's a material here that's going to be moving slowly. It will be rotating slowly, and there's also one abrasive stick that will be moving back and forth, um, reciprocating in reciprocating motion, so that it will cover all surface of the work material. So super finishing is usually to get a very super fine surface compared to the honing, which you want to create the crosshatch surface. But for super finishing is you want to get a very good surface finish.